Hello everyone, my name is Nikhil Gajjam, working as Assistant Professor in Department of Computer Science and Engineering in Walchand Institute of Technology, Solapur. In today's video, we will see programming with linked list. In this session, we will see a function to find out the loop in the singly linked list. Now we have to find out whether a singly linked list containing a loop or not. Learning outcome: at the end of this session, student will be able to write a function to find the loop in the singly linked list. Now singly linked list with the cycle, if you see the diagram, this is the singly linked list. We all know that what is singly linked list. Linked list is nothing but the collection of nodes, interconnected nodes, and each node consists of only one pointer, that is next pointer, and that next pointer holds the address of next node, and data value, it holds the integer value. Head is a pointer which always points to the first node. The normal linked list is singly linked list will look like this, where head or a start is a global pointer which always points to the first node, and last nodes next will have the value null indicating this is the last node. Now if assume that if singly linked list contains the loop like this, where there is no null pointer. Now we have to find out whether the singly linked list containing a loop or not. Now there are multiple approaches are there to find out whether the singly linked list containing the loop or not. We'll see one of the approach here. Now detect loop, it is one of the function we are going to write. Now how to find out whether the singly linked list containing the loop or not. Now traverse the linked list using two pointers. Normally we are traversing using one pointer. Now here we are using two pointers. These two pointers we are saying that slow pointer and a fast pointer. Move one pointer, assume that is a slow pointer, by 1, and another pointer we call it as fast pointer by 2. If these two pointers meet at the same node after some traverse, then there is a loop. If pointers do not meet each other in the linked list, then we are saying that there is no loop present in the linked list. So we call it this approach, we call it as tortoise and hare approach also, where we are using two pointers. One pointer will move one step ahead in each step, and another pointer will jump to next to next node like this. We will see a diagrammatical representation. Suppose initially there are two pointers, we call it as P and Q. Both are pointing to the first node. So after first step, one pointer will go to next node, and another pointer will go to next node like this. So it will skip one and will jump directly to the second node like this. So this is here P will act as a slow pointer, and Q will act as a fast pointer. So next step, P will go to next node and Q will go to next node like this. Now the same approach will go on continuing. In the next step, P will go to this node and Q will jump to this node like this. Okay, we'll see diagram this. We'll find out whether P and Q meet each other after some traversal. We'll copy this. We'll copy this, paste this. So initially P and Q here, right? Next time P will go here. So this is your P and this is your Q. Okay, like this. Next step, P will go here. P will go here. This is your P, and Q will jump to here. This is your Q. Okay, like this. In the next step, P will go to next step. So this is your P, and Q will jump to next, matlab like here. This is a Q. Okay, next time P will come to next node. So this is your P, and Q will go to next matlab means here. This is a Q. Next time P will go to next node. So this is your P, and Q will come to next means here. So this is a Q. P will go to next step. So this is your P, and Q will go to next means here. So this is a Q. So after next step, P will come here and Q will go to next means here. This is your Q. Okay, then P will come here. So this is your P and Q will come next means here. So at this point, P and Q both are pointing to the same node. So after some steps, P and Q, both slow pointer and fast pointer, will point to the same node. So it means that when P and Q, or slow pointer and fast pointer, pointing to the same node after some iteration, so then we are saying that there is loop present in the singly linked list. Again we come back to PPT. Now this is a code. This is a code for detecting the loop. Again, this is a recursive call. This is a function detect loop. What we are passing? Struct node star list means we are passing start or head or address of first node to the function. Struct node star slow pointer is equal to first node and fast pointer is equal to first node, address of first node. Both are starting from the first node. So while, so we'll continue this loop till slow pointer is not equal to null, fast pointer is not equal to null, and fast pointer arrow next is not equal to null. So both for slow pointer and fast pointer should not reach to the end of linked list. If either of slow pointer or fast pointer has reached to the null, it means that singly linked list don't have the loop. Now slow pointer is equal to slow pointer arrow next. At each step it will go or traverse by one next node like this, and fast pointer will skip the next node and go to second node like this. So fast pointer is equal to fast pointer arrow next like this. Okay, so it will skip the next node and jump to the next node like this. If slow pointer double equal to fast pointer, if at any stage slow pointer and fast pointer both are pointing to the same node, return 1 matlab means a loop is present in the singly linked list. So the return 1, it is returning 1, this function is returning 1 value to the main function. So in the main we are saying that if this function is returning 0, so there is no loop present in the singly linked list. If this function is returning 1, then we are saying that there is a loop in this singly linked list. Now program, we have seen the program. Now think and write. What will be the time complexity for detecting the loop using this approach? You can pause the video and you can answer. Answer for this is big of n. Now, we'll see how the answer is big of n. So when we traverse, for detecting loop we are using two pointers, P and Q, or slow pointer and fast pointer. So slow pointer will go one by one step and pointing to the next node like this, and Q, it will jump to the next node like this. So P and Q will traverse the singly linked list at least once. Then only we are finding out whether the singly linked list containing the loop or not, like this. So it requires at least one traversal to find out whether the singly linked list containing a loop or not. No, obviously that Q will require n by 2 and P will require n complexity, because P is moving one by one step and Q is moving skipping one node and jump to the next node like this. So complexity of Q will be obvious n by 2 and complexity for P will be n. So overall it will be n plus n by 2 is nothing but big of n. So big of n is nothing but one traversal. So at least one traversal we require for detecting the loop in the singly linked list. So answer for this, time complexity for detecting the loop is nothing but a big of n. Okay, these are the references I have used for creating this video. Thank you.